So I'm going to tell you a few more stories now about, and hopefully at the end you will be able to distinguish these kinds of nets: the ARPANET, the ALOA network, the Ethernet, the Internet, and Wi-Fi. And by the way, I've not checked any sources. I've not attributed anything to anybody. This is just thoughts on slides. So Claude Shannon was a famous connectivity theorist, and he focused on a single channel and understanding its bandwidth and how one deals with noise. But there are many other, by the way, this is Claude Shannon. I have no idea what he actually looked like, but, and there's his math in the background. But he just focused on the communication, the connectivity of a single channel. There are all these other issues in connectivity that need our attention. And I've listed some of them here. It's a very long list, and this is where I've been working most of the last 50 years. Let's see. So at the beginning of those 50 years, this was my personal computer. It's an IBM 1401. It was mine every night from midnight to 8. I worked at. So you would punch in your program and its data into this punch card machine, and you'd make a deck of cards, and then you'd take the deck card reader, and it would then run your program, and the next morning you would receive a printout from the 1403 printer, full of error messages generally. Batch processing of punch cards on mainframe computers. The new generation was coming along, and these are the computers that ARPA agency, the Department of Defense, ARPA, sought to network with the ARPANET. These are PDP-10s, interactive time-sharing systems, and this is a teletype, an ASR teletype. So instead of typing your programs into a deck of cards, you would type them into a piece of paper, and the computer would record them and later print out your answers. And you'd get your answers in 5 seconds, not overnight. So that was a big leap forward. These are the machines for which the ARPANET was built. My former boss, Bob Taylor, may he rest in peace, was the guy who was the computer science sponsor at ARPA. And he had sponsored 3 PDP-10s to do different research. And he had 3 of these teletypes in his office. And he said, well, I don't need 3 teletypes. I only need 1 teletype. So let's build a network that would allow me to have 1 terminal in my office and log into the 3 different PDP-10s. That was my version of the beginning of the Internet. So the way I got involved is I convinced MIT to let me build this device. And this device today would be a chip. These are MSI chips. You know, one of those chips might have 2 flip-flops on it, for example. So I built this to connect a PDP-10 into the packet switch. So ARPANET was a bunch of interconnected packet switches, data packet switches. MIT got one on the 9th floor of Tech Square in Cambridge, and I got one of the ports. My job was to build this 1822 interface to connect MIT into the Internet in 1970. And so here we go. On top of that hardware that I just showed you, we developed a Telnet protocol. The first protocol of the Internet was Telnet. And it implemented the ability to do resource sharing. And the resource sharing we're talking about is the kind Bob Taylor wanted, to be able to log in at a remote host. So you're sitting at your desk, typing away, and you specify what remote host you want to log into, and you log in. And that was to accomplish the killer app of the intended killer app of the Internet, resource sharing. And by the way, on October 29, 1969, a packet switch was turned on at UCLA, and Professor Leonard Kleinrock reminds us of this all the time. This is UCLA being the first node on the Internet, and he deserves it. And his grad student, Charlie Klein, was going to log in from UCLA in Los Angeles up to SRI up in Menlo Park. And so he cranked up the Telnet software, and he typed L, you know, the beginning of logon. And then it echoed and printed out on his terminal. And then he typed O, and the O came back and printed out on a terminal. And Then he typed G, and all the computers crashed. And that was the first internet packets on October 29, 1969. They eventually fixed the telnet, but that was the first one. So this was the internet, the resource sharing internet, 1973. And I call it the kilobit internet because these trunks connecting the coasts of the United States, these intracontinental links ran at 50 kilobits per second. I know you're not used to the word kilo anymore. We thought this was the coolest network in the world. It went 50 kilobits. That's an evolution of this network. Skip this. So there are the first two big transitions that the internet took is, first of all, back when it was still called the ARPANET, surprise, there was a transition I just mentioned from resource sharing to email. And this was email mostly on PDP-10s. But then a second surprise happened. We started out using these paper terminals. And by the way, that's a box to catch the Chad from the paper punch right there. We then switched to glass. These were called glass teletypes, but they were still dumb terminals and interactive. And then later came the transition to personal computers, about which I'll say more. So that's two transitions: resource sharing to email, dumb terminals, glass, PCs. So there I am in 1973, 72 it says, in my office at the Xerox Research Center, and I just finished putting Xerox on the internet, and I had nothing to do. But the Xerox Research Center, the computer science lab, we decided to build the world's first personal computer. It was called the Alto, and it was built during the year 1973. But then the group of, 10 of us at a meeting, we need to connect these together. Who's going to do that? Hey, there's somebody in the room who's done networking before. Why don't we choose that person? So that was a big moment in my life. I got the job of networking a building full of personal computers, a job that had never existed in the history of the world. No one had ever had a building full of desktop personal computers. So this was my dumb terminal, a Texas Instruments Silent 700. This was 30 characters a second, 300 bits per second. Up there is a box of 35 millimeter slides. I was on the board of the company that delivered PowerPoint. We sold it to Microsoft, but this is 1972. We didn't have PowerPoint. So everybody who gave presentations had 35 millimeter slides and a carousel projector, and there's mine. And here is an actual Rolodex, and here is that silly telephone, and here are things called pencils. And this is an IBM Selectric typewriter upon which I typed the memo inventing Ethernet. And I'll show you that in a minute. So, but it didn't make the photograph, so I patched it into this photograph. So this was the environment immediately prior to the Alto PC interneted by Ethernet. Yes. So this is the memo, a piece of the memo. May 22nd, 1973. David Boggs and I worked on this together, may he rest in peace. We decided that this network would have a shared coaxial cable. And PCs wanting to inject packets or receive packets from that cable would tap into where they were, it would tap into the half-inch coax and packets, and it would inject packets into this coax, and then the coax would carry them, and the stations would look for their address in the packets and copy them in. And we imagined a variety of devices connected. We also envisioned carrying packets between locales on a telephone network. And these would be called routers today. I call them boosters back then for some reason. And then way over here on the right, what does that say? So I invented Wi-Fi? I like annoying the Wi-Fi people by saying that. No, we anticipated, Ethernet wanted to be wireless. I even spent a month in Hawaii at the University of Hawaii looking at the Aloha packet radio network. And I learned two things in Hawaii. Yes, we could use their method of media access called randomized retransmissions, which we adopted for Ethernet. I also learned there was no chance of our using radio, because the radio modem that ran at 10 kilobits per second was this big. And the PC we were networking was this big. So we were not allowed, our constraint was to get on a card of 60 chips. So we were not able to use radio. We had to wait 25 years for the semiconductors to arrive in mid-90s. So we cabled in the internet. It was an interim solution. And this is what it looks like when you're debugging this is the first Ethernet card being debugged right here. So this is the principal constraint on our design. Whatever we designed had to fit on that card right there. And of course, this is the rest of the PC. Now, having been given the job to do Ethernet, you might think I'd just go off and do it, but no. There was competition in the lab. Now, competition is a good thing, except when you're being competed against, and there they were. So the sneaker net was one of our fierce competitors, and it always crops up. The person says, I don't need your network. I just put on my sneakers, pick up my diskette, go down the hall, put it in the printer and print. So I'm going to use SneakerNet. I'm not going to use Ethernet. It takes about a month to cure them of that disease. So we invented Command P, or Control P, well, your favorite character. My favorite competitor was Signet. Signet was short for Simonyi's Infinitely Glorious Network. And it was being designed, when I arrived at Xerox PARC in '72, it was being designed by a man named Charles Simonyi. And Charles was taken off the net. When I arrived, he was taken off the network project because that was not his specialty. And he was given the job of writing a text editor called Bravo, which became Microsoft Word. And then it became Microsoft Office. So Charles is the fourth billionaire of Microsoft, and I could have had that job. Another form of competition, oh no, was XNet. This is more sinister. So David Boggs and I are building this Ethernet, struggling to get it to work, and we had a 1 month pause where we just couldn't get the transceivers to work. And one of my colleagues, who hated me, and I hated him, completely normal hate thing, he announces that he's developing XNet because Ethernet's not going to work. So we need a network really soon because the PC is going to be ready any day now. So he announces he's going to build XNet. Well, this is devastating because this is a powerful colleague, and he was about to suck all the oxygen out of the room with his damn XNet. But XNet was really a bad idea. It was 16-bit parallel. So there was a cable about this thick, which you can't run all over a building. So it was a really bad idea, and it died early. Let me move on. So there it is, arguably, the first personal computer networked in 1973. Does anyone have a question, by the way? Anytime. Yes. Why is it called Ethernet? David and I considered various media, like radio, like coaxial cable, like twisted pair, like optical fibers, and we chose coax. But we realized in the long term, we might not come up with that same answer in the future. We might want to use radio, for example. So we didn't want to call it coax net, because that was too specific. So we looked for a word that would admit to having multiple media, different media. And ether came from physics. Ether was, well, you all know this probably. In physics, they said for the longest time that there was a medium called the ether that carried light from the sun to the earth. And in circa 1905, they proved that it didn't exist. So that word was available. And we took the word, we adopted it. And our first adversary was a physicist. This is a terrible idea, this Ethernet thing. Why, you've even named it after a discredited physics phenomenon. Like we didn't know what the word ether was, and we were just being stupid. Anyway, he'll never live that down. So speaking of living things down, I left Xerox in 1979, and in June of '79, my phone rang. The guy named Steve from a company named Apple in a city called Cupertino, and I'd never heard of any of those three things. And I lived in Palo Alto. How come I never heard of Cupertino? Which is, anyway. Steve said, how'd you like to come talk to me about networking? Of course, his company had 20 people, 30 people. And so I met him at a hippie food joint on Stevens Creek Boulevard in San Jose. But I came prepared. I had a proposal for a network to sell Steve. And follow carefully. I called this network Orchard. Get it? Apple. Well, Steve didn't get it either. But I told him I had just started a company, and Steve did a wonderful thing. He helped me build my company. So I'm a Steve Jobs fanboy. He did insist, when it got time for me to raise a venture capital, he insisted I buy an Apple II and that I run VisiCalc on it. And, oh no, I'm sorry. Well, this is going to be a great presentation. You've seen the presentation now. There it is. This is the business plan that I raised money, I raised $1.1 million, which is a laughably small amount these days, to fund 3Com. This was the business plan. This is the spreadsheet from VisiCalc that was running on the Apple II that I bought at full price from Steve Jobs' company. And so we created the normal Silicon Valley system, the inventor, the investor, and the adult supervision. A lot of people don't realize that in Silicon Valley, adult supervision is a term of art, and it's an important concept. It says when you start a company, there's a good chance you have no idea how to run a company, so you want to recruit somebody quickly who knows how to run a company, and that person is called the adult supervision. And a lot of people think Steve Jobs was a phenomenal CEO, and he was eventually. But he founded Apple in '76, and he was CEO in '96. So Steve learned how to be a CEO over time. Anyway, there was our Bill Krause's name. When he joined the company, we had 12 employees. When we kicked him upstairs to chairman, we had 12,000 employees. So you could say he succeeded. We also lucked out. In 1981, IBM introduced the IBM personal computer, and we figured out how to get Ethernet inside that baby. So we made a card about this big. You could plug it in and put it on an Ethernet. The card cost just under $1,000. Take two, they're small. And then in the marketplace, we learned about Ethernet. We learned these lessons. The Gerald Manchester Aloha Network Ethernet was not what people wanted. So that's the original, the Gerald tap into the coaxial cable, Manchester encoding of the packets so that the packets would contain their own clock, so you wouldn't need a global system clock. And the Aloha net with randomized retransmissions for getting your packets on the network without colliding with others very often. All three of those are gone now. They're not part of today's Ethernet. Ethernet isn't gone, but they're gone. And now we realize what Ethernet really accomplished. First, Ethernet brought packets to the desktop. Prior to Ethernet, the packets would get stopped by the host computer, which would then feed them to an application that would then type on your terminal with a dumb terminal. But with Ethernet, those internet packets would come all the way to your desk, and so you could write arbitrary programs that could network natively. My favorite example is the World Wide Web. It was programmed on top of all that plumbing. Second, the Ethernet that hit my desk was 10,000 times faster than the terminal speed it replaced, 2.94 megabits per second. not 10% faster, not 100 times faster, 10,000 times faster, making practical the uploading of cat pictures and other stuff. And the third thing that Ethernet did is it joined the march of standards. So Internet is largely a standards movement, and now Ethernet went through a standards making process, and that persists. Packets to the desktop, abundance of bandwidth, and standards. Now, it's a chaotic world we live in, so while all this is going on, as we're developing Ethernet and we're making a company to sell it and so on, people are working on the internet, but look how hard it is. We started with punch cards, quickly moved on to dumb terminals, then moved on to workstations and PCs, then we networked the PCs in local area networks, then we moved into client-server computing, and then smart mobile video phones, and now we're moving out to the edge. And all this is happening at the same time. It's very confusing, and it's particularly hard to have products because you don't know which products to have. And then the internet started disrupting things. I'm not going to go through this, but you know, just as my main example, the internet was not built to carry video or be mobile. Today, it is almost entirely video and mobile, and that's where all the growth is now. So no mobile video, all mobile video, big transition. And that began these disruptions, and I won't go through these, but my favorite ones are advertising completely disrupted, journalism, they still don't know how to finance journalism, commerce more generally, telecoms, TV, dating, retail, slide presentations are all disruptions delivered by the internet. But the big disruptions are just around the corner. Those are nothing compared to what's coming, because now the internet is disrupting work, hybrid zooming into work, learning, eliminating universities. I'm sorry. And healthcare, energy, transportation, major disruptions ahead. Now my favorite, so is the internet good for us? And that's a current topic. There are people who want to shut down the internet. They have reason to be worried, but their recommendation isn't correct. They want to shut down the internet because people get lonely using it. And I think the internet is worth more than that, and maybe that's not the cause. The internet is not the cause. This is a plot of poverty versus time. And I've drawn two lines, going back to 1820, out through 2015, it continues. And this is poverty, and this is people in extreme poverty. And you'll notice people in extreme poverty goes up and up and up and up. The internet arrives, it continues up for a little while, and then for the first time in human history, it turns down. Yes, I know the difference between correlation and causality. But I've always believed that correlation is the first step toward causality. And so I'm arguing briefly here that the internet is having a major impact across economic activity on the planet, and it's making this a better planet. Now, there are some things that go wrong. The internet came so quickly, starting on October 29, 1969, that we don't really know how to manage all this connectivity. So think of the pathologies of the internet. The first one was hacking. 2 high school students hacked into the internet, the ARPANET in December of '73. I wrote the memo documenting it. That was '73. We still have hackers hacking our systems. Pornography became a problem, so much so that the United States government almost shut down the internet because it was so good at carrying porno. They passed a law called the Communications Decency Act, intended to fix this problem. It was declared unconstitutional a year later, and now there's no more porno on the internet. And then advertising, a most interesting case, it became a pathology. People started putting ads on our internet. And it was obnoxious. And lawyers were involved, and marketing people were involved. It took a year or 2 or 3 for us to realize that advertising would be the source of almost all money on the internet. Building out the internet, operating the internet is all done with advertising dollars. So that's an odd flip. And we do talk about spam now and then, but not much. When's the last time you've had a conversation about spam? So spam sort of has been handled. So my optimism is that the current pathologies are going to be handled too. And the ones that are really have our attention: addiction, loneliness, suicide, censorship, fake news, misinformation, a horrible list of things. But we're working on this. You're working on this. You must be working on this. And we're going to fix that. This is the first ad on the internet, 1994, AT&T. It's a paid ad. It's a little blurry, but have you ever clicked your mouse right here? Who writes ad copy like that? I don't know. Now, some big things happen. I've only chosen 3 here. They're surprises. Innovation and connectivity are full of surprises. And here's 3 big ones. By the way, where's the clock? What time is it? 4:10? Oh, there it is. And when would you like me to stop? Good. Oh, I can finish in 20 minutes. A guy named Herb Grosch was an IBM executive in the 50s, and he had data. And he plotted this data, and he proved with his data, and IBM was 90-some% of the market for computers, that the cost of a mainframe computer went up as the square root of its power. A consequence of which is bigger computers are better. And this law, Grosch's law, was adopted universally on the East Coast of the United States, where you could think of the East Coast then, in the 70s, as being Silicon Valley, but it hadn't moved yet. But we were in the grips of Grosch's law. It turns out another guy, Moore, developing semiconductors on the West Coast, his law implicitly is smaller computers are better, and it's smaller network computers are better. And he was proven right, and so Silicon Valley moved. This is, I'm not exactly sure whether they're putting the sign up or taking it down, but Silicon Valley in the early 70s moved to the West Coast, and I think principally because of the mistaken belief on the East Coast of Grosch's law and the winning belief on the West Coast in Moore's law. And there's Gordon Moore, may he rest in peace, correcting me, saying, my law has been numerically true since 1965. Boy, what about your law? How come you didn't? Anyway. Now you find connectivity in places other than the internet. I thought I'd bring 2 up, at least 2. Right now, you all know about the Voyager? In 1977, they launched 2 spacecraft. In 77. And there's a little house in Southern California with a crew of people who are tracking these 2 spacecraft since 1977. And they were adjusting it and tuning it. And it has connectivity. It has a radio. It's a radio powered by plutonium power supplies. And it's so far away, what is it now, 20 billion kilometers now, but it's receding at 35,000 miles an hour. Oh, I'm sorry, I mixed units there. So this radio is far, far away, and by now, as the plutonium wears down, it's now sending bits back to Earth at 160 bits per second. It's getting through. And that radio uses Manchester encoding. So vindicating the decision that Dave Boggs and I made in 1973. And then here comes artificial intelligence. There's a paradox. The paradox is this: neurons are huge and slow. Transistors are tiny and fast. So why is it that you can build smarter devices with neurons than you can with transistors? You see the paradox? Well, why is that? And we know the answer because of the title of my talk. Connectivity. It's connectivity that explains this paradox. So transistors are 1,000 times smaller and 1,000,000 times faster. So that's a huge paradox. So look at CPT-4. That's AI, right? What's that?
Yeah, it's AI.
Yeah. I'm not getting much of a response here. Yes, CPT-4 is AI. And CPT-4 has 176 billion parameters. A parameter is analogous to a synapse or a connection in the brain. And you take brains, on the other hand, of 10 to the 11th neurons and on average 10 to the 4th synapses per neuron. So that's 10 to the 15th. So there are many, many, many more neurons and connectivities in a brain than there are in the computer. And that's the limiting factor. So I'm just looking at connectivity, and there are other factors in the performance of neural nets. But we have a ways to go. If you look at the 175 billion parameters and the human brain, and you assume that connectivity determines the performance of this network, then we need 5,700 times more connections to achieve AGI, human intelligence. You'll see pictures like this a lot that show, look, neurons and transistors are almost identical. The trouble is one of these is 1,000 times smaller than the other, and the number of connections of a neuron are many, many, many more times than this. So this diagram, forget it. Okay, now COVID arrived in 2019, which happened by coincidence to be the 50th anniversary of the internet. It is almost as if we built the internet for COVID. Zoom came to the rescue, Zoom and Teams and the others. And now all of us, including the army of professors who informed me prior to this that they would never teach a course over video, because never do that, because you want to be in the same room with your students. And then COVID came, and all of them at the University of Texas are taught using video, and it pretty much worked. So now we've all had a taste of video collaboration, and that's going to play out over the next 2 decades. Where we work, how we work, it's all going to play out. And so I'm proposing as my final contribution this afternoon that we change the meaning of the acronym COVID. It's now short for collaborative video. So the most important new fact about the human condition is that we are now all suddenly connected. 5.8 billion of us since 1969, 65% of the population of Earth. Thank you. Are there any questions? Thank you. How about a hostile question? How about a stupid question? There we go. Is that hostile or stupid?
Hello, that was a great presentation, sir. I wanted to ask, according to you, what made Xerox PARC so successful and such a source of innovation?
Right, that has been a subject of considerable attention over the years, because a lot of computer science breakthroughs came through at Xerox PARC, including the first personal computer and Ethernet, I might add. The lab was run by a guy named Bob Taylor, who, may he rest in peace, who previously to working at Xerox PARC ran computer science research at ARPA, the Advanced Research Projects Agency of the Department of Defense, which at the time was sponsoring all computer science in the world. And Bob Taylor ran that for a while, and so he got to know every computer scientist in Earth because they were coming to his office to get money. And then ARPA lost him to Xerox. Xerox gave him the job of building our CSL at PARC, And he knew everybody. He knew who all the good ones were because he had been working on that for years. So I think that contributed. The fact that Park is in sunny California contributed in Palo Alto. It's sort of a lab of Stanford, approximately. And then Bob Taylor ran the organization like a university lab, not like a company lab. So we published papers, we gave lectures, and many of us were faculty at Stanford. I was a consulting professor at Stanford for 8 years. So I think that explains it, especially the weather. Oh, but you have great weather here too. That must explain why Hyderabad is so successful also. You think it's all weather? You think it's just weather that determines success and innovation? There's a lot of evidence to support that. Did I answer your question?
Yeah.
It helped that Xerox was a monopoly at the time, a copier monopoly, and had a lot of money and spent it on computer science research. That helped too.
I'm sorry if I missed it, but what exactly is the problem with connectivity? We can just like connect those systems. Is it the speed? Is it the number of connections we can make physically, or within the transistors, as much as there are with neurons?
I didn't catch what the question is. I'm sorry.
The question is like to match the level of human intelligence. If I understood it correctly, is the number of connections or other parameters related to connectivity within those transistors, or other electronic components where.
What is the challenge? Why are we not able to get the connectivity at the level of human brain?
Well, because the semiconductor technologies have just gotten to where you can build a neural net with that many connections on it. So my undergraduate thesis at MIT, listen to the title of this thesis. I wrote it in 1968. The title was A Neuron Model and Some of Its Information Processing Capabilities. And there I viewed the network of neurons as a computer, an analog computer. That was a bad model. The one you're asking about, I'm trying to answer, is I'm doing a little hand wave, rough, seat of the pants estimation. People wonder, when are we going to get to AGI? And being a connectivity advocate, I'm saying, look at the connectivity, and you need more. We need 5,700 times more connectivity. That, of course, assumes that I'm right about the intelligence of the network being correlated to its connectivity. I mean, that's a key assumption. It's an unproven assumption. So I asked the guys in charge of OpenAI, and I say, will Chat GPT-5 be 100 trillion connection parameters? And they say, I can't tell you that. That's a proprietary secret.
So the question I have is, what do you think about connectivity in the metaverse? And what are the challenges in metaverse related to connectivity?
I'm not really an expert on the metaverse. I'm not sure I believe in the metaverse. You mean there's another copy of all of this? Is that the metaverse you're referring to? Oh, I withdraw from that question. I don't know how to answer it. I honestly just have nothing to say.
Sir, I had a doubt. Do you feel that AI and ML can be incorporated into connectivity on a large scale? I mean, till date, we use algorithmic encryption and decryption, and even security, we are using algorithmic techniques. Do you feel that we can incorporate machine learning into a large scale in the connectivity sphere?
Y'all are asking hard questions here. How successful will be applying machine language math to intelligent neural nets? I think we're going to be very successful, but I have a warning sign. So I just bragged that I've been in AI since 1968, and I've watched AI go like this. like expert systems. It's going to change the world, and then it didn't. And so now we have a new wave, the fourth or fifth. The preceding waves have all crashed because the neural nets got starved for data. There wasn't enough data for them, so they just went away. This time we have the whole internet feeding our neural net, so there's a very good chance it's going to be successful, and that's why I say it will be. But there's a new phrase I've begun hearing, model collapse. Have you all heard that? It's where you have your LLM and your training and so on, and eventually you've sucked all the knowledge out of the data you have, and your model collapses. And that would be why, if that's likely to be if and when AI goes crash this time, it's probably some form of model collapse that's going to get it, I think.
Hey, hi Bob. Very interesting talk, in a way nostalgic, because with the white hair I could relate to years ago, decades ago, flipping those flip-flop switches on PDP 1170 to boot that. So it was really very nostalgic.
My hair is gray?
I'm talking about my hair. So my question is really, it's more about an observation. Connected, great. Of course, we all be connected, and that's the most important thing to happen. But once you're connected, you need to interact, exchange ideas, views, information. And the medium for that is going to be language. If you look at languages today, typically talking about India, there are more than, I think, about 22 languages which are recognized by the Constitution of India, and almost like 1,300 odd majorly spoken languages.
Is that a plus or a minus, by the way?
It's just a big number. It's a large
That's a serious question.
Is
it good that we have so many languages or not?
We do have a lot of languages in India as per the Constitution of India. There are about 22 languages which are recognized as the official language. Official is actually 2, recognized languages by the Constitution. The number of major dialects which are spoken in India are over 1,350. Every 100 kilometers you travel, the taste of water, food, and the language changes in India. My question is that when you are connected, the big challenge is to convey ideas. I just want your reflection in terms of, in the future, 10 years, 20 years, 50 years, are we going to see a likelihood of a universal language emerging so that we are able to then communicate as one global community?
You're way out of my area of expertise, but that won't stop me from commenting. I'm serious about the question. Is having 25 languages a plus or a minus? And that leads you then to the perennial question, is it better to standardize or to translate? And now we can sort of ask that question because we have what strikes me as a very good translation is emerging. I mean, I typed into chat GTP4 and out came Spanish. I don't speak Spanish. But that perennial question, and it occurs in the area, lots of different places, particularly connectivity. Is it better to standardize or to translate? And when you have 25 languages, there's a lot of translations there. And a lot of those languages don't have a vocabulary appropriate for what's happening in the world. So I don't know what you do with that. And this is philosophical, and there are people who love the variety of languages, and God bless them. Is my hair still gray?
So mine. No, I think that's really a very interesting aspect, because like food, the variety is important. We all like variety. If you're going to have bread butter every day in the morning, it will not really work. So therefore, variety will be there. But there should be some kind of a uniformity so that the ability for us to communicate ideas effectively, globally across communities and continents and things like that, after getting connected, is something important. So I was just wondering, would there be, I'm just thinking loudly, would there be any concept of a universal language, which is like standardization of languages, the vocabulary, the construct, culture will be difficult to get and things like that. And of course, till the time we do that, translation is a must. So we have to keep translating.
Well, it's either There used to be in National Geographic magazine a chart of the number of languages in the world. And what do you think the shape of that curve was? It was a declining exponential. From 150,000 languages to 70,000 languages. So whatever you and I decide between us we're going to do about it, there's already a trend. And I think it's revealing the inefficiency of having multiple languages. And as lovable as these languages are, maybe we're watching them get selected out. Now, the standard language thing has been tried, as you well know. It didn't work out. What was it called again? Esperanto. I don't know why it failed, though. It could have failed for another different reason. Oh, so I question one of the assumptions that you've made. You said we're going to interact through language. And a lot of the communication that's going on these days increasingly is video and audio and not written text. So the nature of this interaction that you're arguing for is changing right in front of us, these things. It's a very interesting question. Thank you.
So first of all, thank you so much for this lovely presentation. So my question is, where do you see IoT, or more specifically, industrial IoT, getting to in the next 5 or 10 years?
Your question was great until
Internet
you
of
put a
Things.
time frame on it. Because it's easy to predict anything, but getting when it's going to happen is the hardest. So IoT is edge IoT. I put them together. Is the next big thing in computing architecture, and the question of whether to have standards or translators occurs there. So we don't know what the standards are going to be in IoT edge, but we do know it's going to be big, and so we think it's going to be big. So 6G, 5G, 6G will allow much more, make it much easier to have IoT edge computing, but it's not here yet. I think that the hardest part of IoT will be the standards. A lack of standards will persist for too long, and that will slow it down, I think.
Thank you, sir. So my question is, when we talk about AGI, do you think AGI is a function of connectivity, or do you think there is more to creativity or imagination?
You're mixing data types there. Connectivity is, involves wires and electrons and stuff, but imagination and creativity have other units. Let's see. Human intelligence is not well defined. So AGI, if we achieved it, we're not sure what it would be. Would it be the ability to cook or the ability to read? So we don't even know what the goal is, and we're worried about achieving it. We're all going toward AGI. The Turing test, I guess, has been passed by now. Every time I sit down in front of GPT-4, I am convinced the Turing test has been performed by now. It's amazing. What's the core of your question, though? Imagination, and how would that be an alternative for AGI?
The question is connectivity alone is sufficient? Or you need something more?
Yeah, so for example,
Yes.
when we talk about, so I'm forgetting the name, but there is very computer science famous personality who has recently said that ChatGPT is most likely is like learning a lot of it's learning a lot of patterns, and based on that, it's giving those patterns. It's not actually creating something. So he says that it's very different from like how human imagine something which is not there. For example, invention of internet or invention of art.
Once again, this is out of my bailiwick, out of my beat, but so I think AIs can be every bit as smart as human beings and can be creative. And the people who say there's something different about AIs that keeps them from being creative. I don't go along with that. We just need to make them more creative.
Thank you, sir.
But once again, I'm not a leader in this particular debate, and it's dangerous. There's at least 5 people here who hate my guts now, having said that.
Thank you, sir.
Because we're talking about the existence of the soul. Is there a soul in the machine? When I first wrote a program for the alto, I wrote the Lord's Prayer in BCPL. And then every time I used my machine, I would start that up in the background, constantly praying, hoping my programs would work.
Hello, sir. If we are more connected than ever, why are we more lonelier than ever? And most importantly, what are we going to do about it?
I didn't understand that question. I didn't hear it really.
Okay. If we are more connected than ever, then why are we more lonelier than ever?
I'm sorry, please somebody help me.
If we are more connected, why are we becoming even more alone? More lonely. More lonely.
Why didn't you say so? Once again, this is not something I know anything about, but I think there's a plausible theory that loneliness can be created by sitting in front of a computer all day. And I personally am scarred for having done it for 50 years. It's the correlation, suicide which is a horrible manifestation of all this, has bloomed in the US along with this technology. So it's easy to say they're correlated, that this new technology created this impulse. But I don't understand why being connected to more people is bad. And I guess what you're saying is they're using the network how are they using connectivity if they're lonely? These people, these sad people who are killing themselves. Well, how can they be lonely? They're connected to billions of people. Maybe there's a bug in our software that prevents them from being connected. And then the worst thing is polarization, where groups of crazy people get together and have crazy thoughts. And they're validated by the fact that other people believe in them too. Ooh. And that leads to polarization. So we're working on that one too. Not me, but someone's working on that. I'm sorry I didn't understand your question. I'm not hearing that well.
Thank you for the wonderful presentation. I have 2 questions for you. The first one being, what was your idea of evolution of internet like 30 years back? And how is it different from how internet has actually evolved?
So I was at Xerox PARC when that question would have arisen for me. And we did not anticipate the World Wide Web. That was a 1989 surprise. We did not anticipate the scale of the web. We were building tools and games for our own enjoyment. We weren't building something that would soon have billions of users. So scale was a misunderstanding. We didn't understand the scale. And it worked out differently. There's a lot of scale now. I can't remember a discussion of polarization and suicide and loneliness on the internet until 2 years ago. So there was 48 years of something else. So we were clearly not paying attention to that. That's about it. Oh, and we didn't think of putting video or mobility. No mobility. Wow. How did we make that mistake? Well, we didn't make that mistake. We eventually got around to it. See, with telephones, we used to call a place. But now we don't do that. We call a person. And that's the difference that mobility makes. So if my mom were still around, I would go beyond 3 rings.
So, yeah. So here is a question. Do you think that data cost will impede how the people are going to use internet in future?
Just to go up. Not only are we making networking cheaper and cheaper and cheaper, but the first Ethernet card I sold it for $5,000. Functionality, not because of monopolies and not because of increasing costs. The costs will not be increasing, I think.
Hello. My question is, what advice would you give to aspiring computer scientists? Most people seem to be working in just machine learning these days.
Well, that's an understatement. I surveyed all the websites a month ago, not all of them, but many of them, of faculties at universities. And I'm telling you, I went to all of them, and every single one listed machine learning as their focus, one of their foci. So what we have here is a fad, but fads are good. Using a machine. And it worked. My model could solve Sudokus. Oh well, not a very useful program. How are we doing on time? Are we going to finish? It's 16:41 now. 15? Oh, I have the time. I'm just worried about. Okay, so we're going to end at 1700.
Sir, so you things like that. What else do you see as a potential new era of connectivity?
I did not mean to be skeptical about. You misquoted me. I withdraw. But now you're asking what the next big thing is. Continuous personalized medicine. A very connectivity intensive thing. Something we're on the verge of being able to do. And it will improve our health, and that's a good thing. So I'd answer with that. I'm not doing that, but I would answer with it. Let's talk afterwards. Sorry.
Sir.
Hi, sir.
Hi.
So we have been hearing about this project of Elon Musk of connecting human brain with devices. So how realistic you feel the possibility of connecting human brain with other devices, or maybe connecting one human brain with the other human brain wirelessly with implants?
Yeah, this is Neuralink you're talking about.
Yeah.
And Neuralink just had some sort of breakthrough. They installed a chip in a human being. Holy smokes. So we have a user, we humans have a user interface. We have fingers and eyes and ears. And so what he's talking about is adding another I/O device for the human brain, another way for the brain to interact with other brains and with reality. It's right now working at home. So I have the terrestrial one on. It was $1.1 million. And you're not going to believe this. So I'm sitting there with checks, banging them like this on the edge. And $1.1 million is still a lot of money. So I went to the bank, the Bank of America branch in the Stanford Shopping Center. And I deposited the $1.1 million. And then I walked around the corner to an ATM. And I asked for $500 from that same account, and it gave me the $500. That was the first thing. I didn't really believe I had 1.1 million. But after that test, I was convinced. Yeah. The people who raise money today spend $1.1 million on legal fees. No one raises $1.1 million anymore. But we did, and it worked. We raised 1.1, then we raised 2.2, then we raised 4.4, then we went public and raised 11, and then we did a secondary and raised another 25. That was our funding history.
Hello, sir. Good presentation. I have two questions. First is why radio either was not possible for you guys. Second is, as a team, what are some serious mistakes you have made?
Oh, thank you. I think I already answered the first question. Say it again.
Why was radio either not possible for you guys?
So I already answered that question when I said I went to Hawaii and they had a radio modem there and it was this big. Can't do it. We had to fit the radio on a card this big, not a box this big. So by the way, that box only delivered about 10 kilobits per second, and our network was going to deliver 2.94 megabits per second. So speed and cost and everything, it took 25 years to evolve that technology to Wi-Fi. So eventually we got there, but not then. You're very close to a common innovation topic, which is when you see someone has done something like choosing coax instead of radio, the tendency is to evaluate that decision in today's environment. But the people who make decisions like that didn't make it today. They made it, in my case, 50 years ago. And all the technologies around it changed. So I resent you. What do you mean I made a wrong decision? It was a perfectly right decision at that time, but a lot of stuff has happened in 50 years. Like memory is now cheap. In those days, memory was very expensive, so it was very hard to have a memory-intensive networking scheme, so we shared the coax instead. Now, your second question, what would I have done differently? My life has worked out so well that I don't mess with the past. Do you have another question? I like your question.
Sir, so he's saying in the topic of connectivity, what were your biggest mistakes or setbacks or challenges?
Damn, I can't think of any. Yes, here's one. The way the Aloha network works is if you have two packets in the medium at the same time, they interfere with each other. And then you have to deal with that in short order. And that event, when two packets overlapped in the ether, I called a collision. That was a mistake. Because when we got later into the war, there was a 10-year war about which local area network was going to win, and it was Ethernet versus IBM. And it was fiercely ugly commercial warfare. And I forgot what I was going to say. Collision. So I used the word collision, and then I'd go to battle. So when you hear the word collision, what comes to mind? Two cars crashing, broken glass, blood. And those are the wrong, the wrong feelings you want your people to have. You want it to be. So I should have called it a overlapping transmission event. OLTP, I should have called it, instead of collision. That was a mistake because we had an argument, and the argument was conducted in language. And language matters, the words that you choose. So that word, I think I may have gotten the word collision from Norm Abramson at the University of Hawaii, but I regret using it. Let's see, what else? TCP/IP was being standardized, worked on by Vince Cerf and Bob Kahn, but they were going slowly. And the PC we were building at Xerox was going to be done any day now. So we needed an internet protocol then, not when Vint and Bob were going to come up with one and go through all those damn committees and stuff. So I just invented an internet protocol, a very simple one, and that allowed us to have multiple Ethernets interconnected through routers. And then later, when I left Xerox and went to 3Com, here's where I made the mistake. I should have noticed that TCP/IP was further along, because instead of adopting it, I decided to fight it and introduced a bunch of products based on my own internet protocol. And that didn't help. That was not a helpful move. I made a mistake there. I should have looked harder at the TCP/IP situation. There are pluses and minuses to joining a standard. So that I made the wrong decision. But ultimately, of course, we switched. We were the first company to ship TCP/IP commercially. So eventually we came around. Yes, sir.
Yeah. Hello.
Oh.
Thank you. This was a very inspiring presentation. So, as seen with Ethernet and Internet, right? There might be a time in the future where the current communication system has certain caveats, and with the new nodes emerging that are connected to the current network, there might be some very novel approach of connecting all nodes. What are the basic principles I need to take care of, like in terms of communication and connection?
I'm dazzled by your raising the specter that a prompt will give rise to a new network protocol. So in other words, were you saying, I'm sitting there, I need a new network protocol that incorporates new nodes that look like this, and ChatGPT-7 will then say, well, first you start with a bit field, and then you have a correction, error correction, and an encryption field. It would type it all out, and I'd be done?
I mean, I didn't think of it that way, but that does seem like a probable situation that could happen.
But she's hoping you are the ChatGPT-7 that's going to answer that.
Yeah, right. Well, TCP/IP and the associated protocol bouquet is entrenched. And efforts to update it have everyone that comes by fails. And because of the lasting nature of standards. Here's Ethernet's 50 years old. That's a long time in computer world. So there's something about connectivity which is enduring, and it has something to do with the power of interconnection standards. So standards is a factor in connectivity. You need standards to get connectivity. You get, with standards, you get vendor competition, you get compatibility, interoperability among products. So going to the second half of your question, the role of standards is key in the development of a new protocol. So that would be an early consideration. Is how are you going to get the things to talk to? How are you going to get them to have the right ports so you can connect to it? And that's going on now at the edge. The big fight at the edge is going to last another 20 years probably as to what the proper protocols are. How did I do? Do you have more? No.
Actually, so, so actually a few questions ago, someone asked your advice for computer scientists. I have a different take on that question. In a world where everyone is obsessed with computer science and AI and all that, what advice would you have for an electronics engineer who has no affinity for software? Almost negligible affinity for software.
Change. Everyone should know how to program.
I mean, programming is fine, but at that level, it's.
I'm trying to see if there was a serious question there. But it sounds like you're looking for very generalized career advice. And okay, given I'm not going to do anything in computers, what should I do? That's up to you. But computing finds a place everywhere. Do you use spreadsheets? Okay, so you're programming a computer. You're just using a different language, the cell language, I claim.
Sir, what's the most exciting thing you're working on right now? Right now, what's the most exciting thing you're working on?
Depends how big now is, but geothermal energy.
Hello.
So I think geothermal energy is underrated, and I've joined a movement to bring geothermal to the fore as a way of solving energy. And by solving energy, I mean not just clean, but cheap too. Cleep and sheen. Did I just say cleep and sheen? That means I must stop talking pretty soon. Yeah.
Hello. Yeah. I have one question.
Was that enough of an answer? Okay. You should all look at geothermal energy. It's 99% of the mass of the Earth is over 1,000 degrees Celsius. So why are we burning fuels to make heat? We already have plenty of heat. That's my story.
Yeah. I have one question. A great presentation, sir. So my question is, the first wave of computing was defined by Moore's law. For the transistors, the transistors wave was defined by Moore's law. The second wave of computing, the networking age of Cisco's and Juniper's and Sun Microsystems, the 90s, were defined by the Moore's law and Metcalfe's law, your law. This age of computing, in this age of AI, which law will hold prominence?
By the way, you left my company out of your list. Cisco.
3Com.
I was waiting for this. Cisco. 3Com.
I think it was purchased, if I'm not wrong, the company was purchased for some millions of dollars.
Billions of dollars.
Billions of dollars, okay. Sorry.
And I didn't get half of it. So, very interesting topic, though. What are the laws? There are going to be new laws. So that's another answer to the question over here is when you're designing a new protocol, designing a new anything. What's going on here? Oh, you need laws. So when you're designing something, you should think about what is generally true about what you're doing. And that sometimes leads, not always, but sometimes leads to rules of thumb. And when a rule of thumb grows up, it becomes a law. So it's good to have those in your toolkit when you're designing. But I'm dodging your question, of course, which is what the next law is going to be. Don't you think it has to do with neural nets? Yes, but we don't have a law yet, right? Oh, is NVIDIA broken Moore's law?
Neural network law is the next law. That's his answer. So we'll take the last question, sir. 5 o'clock. So we'll take the last question.
Yeah, it's almost time, so we'll probably. Thank you for the presentation and answering questions from every different direction possible. So my question is a little more generic. You've had a long journey as an inventor, entrepreneur, venture capitalist, right? So for an audience like this, who's aspiring inventors, aspiring entrepreneurs, right? What would your general advice be in terms of how people should proceed?
I like the word aspire. You should aspire. And the rest is details. I'm a former professor at the University of Texas, and one of the saddest things is meeting students who are not aspiring to anything. School bores them. It is so sad. So my first answer to your question is aspire to something. It should be something that's, thank you. It should be something that's fun, or that you find to be fun. Because if it's not fun, you can't be good at it. Because you'll stop, because it's not fun, so you won't get good at it. And to be successful in all the ways that you just listed, you need to be good at something. Like that.
Thank you, sir. On that note, I think that's a fantastic message to end the talk on. Beautiful talk, very engaging. We don't have this much participation in any of your talks, sir. Almost a full house. So I think that's to your credit. Thank you so much, sir, for the wonderful thoughts and sharing your journey. Now request Professor P. J. Narayanan, our director, to hand over a small souvenir, sir.
Thank you.
Our 25th anniversary. It's a local degree, local handmade stuff.
Right.
This region, they make this out of hand, on etched silver on silver on this black.
You'll let me keep this?
Please.
So thank you so much, sir. I think one very loud round of applause for a wonderful human being, wonderful talk. Thank you, sir.
Thank you very much. Very engaging. Very nice audience. Yeah, they were asking all kinds of questions, silly to everything, right? Which is the right part, the right thing to do.
I have a collection of these.